Yeah, so reviewing for test 1, also quiz 2, I have a report that the units are messed up on the image. So I will do a preview. Oh yeah, that says 5 feet. I was wondering why everyone was having a hard time with that one. Yeah, that should be 5 meters. Or I could change those to feet. So like, don't convert, just, yeah. Units. That one's okay. Those are consistent. And those are good too. Yeah. Yeah, so there's 5 questions involving, working with position vectors, working with a bunch of different ways, turning a position vector into a force vector, and finding the angle between vectors. Magnitude of a force along an axis. So that's what the quiz looks like, and you'll get different numbers to solve that. So I guess my question is, this is your review session. What do you need to feel confident going into the test tomorrow? You've seen the practice test. You've seen the solutions are now posted for homework 2. I don't plan to lecture, so it's really up for you to ask anything that you need help on. I don't, at this point, it doesn't really help for me to talk. If you want to work on if you just want to work on the test, if you haven't checked it out yet, you can do that. The link for test 1 is here. And it has the solutions as well. If I can go over some of these problems if people want me to. I can go over any of the homework problems. I graded your homework 2s, but I only graded 3 problems. I graded 101, F25, and F29. I'll hand those back right now. So you can look at the other ones. Everybody very well. Somebody didn't put their name on homework, so you got a 0. So you tell me your name. Remember that? Any questions for you? I'll answer that in a moment. No, just turn it in. So I have this new homework link policy. I think I might have mentioned that. No, that's it. I have another side that has no name on it for homework 1, I think. So somebody's been turning in work and not getting credit for people like that. So who didn't get credit for their homework? That's probably my paper. I didn't get that. Okay. Okay, please put your name on them. Yeah, so I've been thinking about how to, so the thing about this class is that there are online folks and there are in-person folks. And traditionally I've been kind of, I've let the classroom students in the past kind of turn in late homework, but the online students can't do that because it shuts off. I have to have, precise due dates for them. So it's kind of a bias for people showing up to class to be able to turn in late homework. So I've come up with a system that I think is fair for everybody, and that is I have this late homework bin. I think I have. Did I post it? There it is at the top. So, and this sort of is my new late homework policy. You can turn in anything late if you want, but after the original homework set closes, which is Monday at the start of class, then the score will be reduced by 20%, a week later by 40%, and so on, until after 4 weeks late, the homework won't actually get any points. So that way, it's not devastating if you are turning in something in late. And I think it clarifies things about how things are going forward. If you've done everything but the last three, you can just turn it in. That's fine. And this is homework. It's not like a giant chunk of your grade. If you're doing the homework but you're turning it in late, you're still going to do really well in the tests. So I wouldn't fret about that too much. But I just want to make it a fair arrangement for both the online people and the classroom people. So that's why I'm going to institute this for the classroom folks as well. So it's your call. If you didn't do the last three and those happen to be the three that I'm going to grade, then you get 0 for the homework. If you want to turn in what you have now and then turn in the other ones, oh, you're going to drive me crazy, right? So keep in mind that it's just good to kind of turn in everything all at once, because I don't want to get too distracted by everybody turning in piecemeal stuff. 4 weeks from now, turning in like the last problem so just do your best, and it'll all wash out, because I think you'll find it's the act of doing the homework rather than the grade that you get on the homework that really matters. And I think we tend to obsess a lot about like little points that we might be losing here and there. But the big picture is, if you're doing the homework, if you're getting it, that's the thing, right? You're going to get an A anyway, right? It doesn't matter if you lose 5 points on a homework if you nail the test, right? So think of it in terms of what you're learning. Any other questions on that? Okay. So how can I help you get ready for the test tomorrow? How many questions are on the test? There will either be a test so you might have 8 questions. And after midnight tonight, I will quiz 2 all the questions as a practice quiz, like I did for quiz 1. So you can keep trying to do that. And those questions will be the same if I make them multiple choice questions, but they all have different numbers. Multiple choice answers, you got to figure out the answer. So doing those quizzes is really good practice for you. And my plan is to make the final exam. So maybe I'm thinking of having 1 or 2 problems that are more problem solving, rather than having like 6 or 8 problems on the final. Problems. I think I'll have the bulk of it. Maybe 1 or 2 open-ended problems. And then I'm also thinking of instituting, which I'll talk about later, instituting a grading, complex grading, where I grade you based on how complex your answer is, and how. So the real part, how complex the real imaginary part. I was talking about this. My fantasy was to just, not give any like as an engineer, like how close you get to the right answer. So I really started like I would give people like, if you got like within like 2%, you get 100%. But if you get within like 5%, you got 5%. If you get within like 10%, you start getting less and less score based on how far you are from the correct answer, which could be devastating for some people. But I'm like, you know, it's engineering. You got to get the right answer. Right? And then someone said, well, you know, but some people are really good at guessing. And that's actually a good skill, right? But you have to be able to justify. You have to be able to justify your answer by showing the work. If you're an engineer, right, you got to publish your work to show, you know, that it meets whatever you're proving, whatever you're sort of asserting about these numbers, right? So, Tim, you know, the lab tech in physical science, he's like, I've always thought complex. Well, that's a really good idea. He's like, so the real part would be how close you are to the correct answer. And the imaginary part is how effective your solution is. So if you do like a really good, you know, derivation, but you make a couple sign errors, they were way off in the final answer. You know, because it's a complex number, it's like a vector, basically, right? The real part will give you a certain amount of imaginary parts. They sort of, I'll probably draw a picture, but anyway, we should be reviewing for the test, not talking about my crazy grading scheme. I'll explain that more later if I actually do it. I might try it on this time. No. It closes though. Okay. You're worrying too much. Yeah. There are battles, and then there is the war, right? The homework is like the little battles, and the final grade is the war. You want to win the war. The little skirmishes are, you know, back and forth. Homework is worth 8% of your grade, and there's like 15 assignments. So if you completely blow off one homework, that's like less than 1% of your final grade. Sure, well, that's fine. Yeah, you can make that. You can make that, you know, decision on based on, you know, exactly. Do what's right for you. Okay. I haven't had any questions yet on technical material. Anybody need any explanation? Time to do the quiz. You want to go over anything? I emailed you about. Okay, I didn't see that. Sure, absolutely. Oh yeah, you tried to be there. Yep. Mm-hmm. Yep. No problem. Sarah? Sure. So here's the test. If you haven't taken the practice test, you can plug your ears and watch the video later. And what's all this stuff doing, huh? What's all that doing in there? I don't know what that's doing in there. So here's the practice test right here. And actually, let's just do it this way. The question is the angle between the two cables attached to the post. So this one's nice because it involves a bunch of concepts that we had to learn. This involves stuff from chapter 1 and chapter 2, or for homework 1 and homework 2 anyway. And so you might start your solution by writing down a plan first, just to kind of organize your thoughts rather than just sort of diving right in. And how would you plan to solve this problem? Dot product, but that's not a plan, really. Yeah, so we're going to use the dot product. So the plan might be, let's use the dot product, right? But I think of a plan as kind of like a sequence of steps that you're going to follow. Yeah, you want to break it up into the steps that you're going to actually, so it's like a roadmap. How do I get from here to San Jose? Okay, well, I'm going to go out here, turn left, and I'm going to turn right, left, this and that, it's like a map, right? So we're going to find, the first thing we're going to do is what? Sorry? So let's break it down even further. Let's write F1 as a Cartesian vector, right? Well, even, yeah, that's enough, right? So we can write F1 in Cartesian form, or we could just say find F1, right? Erase that. Find F1, and that's going to take a certain amount of time. Find F2, that'll be another significant step, right? And then what? Do we know the formula? If you have your formula sheet, you can look that up, right? What's the formula for the angle between these two cables? So theta is going to equal the inverse cosine of, in this case, it's not A dot B, but it's a regular scalar product in the denominator, right? Not a dot product, right? So theta is going to be the inverse cosine of the dot product of those two vectors divided by the product of the magnitudes, right? Those are parentheses. I was going to put a dot there to indicate multiplication, but then I thought, oh, that's too confusing. That looks like dot product. Mm-hmm. Is that enough, Sierra, or would you like to go through the whole steps? Were you just kind of finding it hard to wrap your head around it, or now that you see it? Yeah. You see, the plan makes everything so nice. Once you have a plan, then it's just like, oh, now it's like now you have your GPS all set up. You just got to follow the instructions that the GPS is telling you to do. Right? Can we go through it? Sure. So the there are a few different concepts in here, which is nice about this one. So finding F1, what kind of representation is F1 being illustrated with? How is F1 being defined graphically? Remember, there's two ways of defining vectors in 3D. F1 is a projection angle representation, right? So F1 is projection angles. How do you know it's a projection angle? Well, when you see those shaded triangles like that, and you have like one triangle that's vertical and one triangle that's horizontal, that's a projection. You're projecting that vector onto the XY plane, and finding its shadow at, at dead noon that it would cast at the equator, if it was hanging out at that angle, and that would be the length of the shadow, right? That would be that red line. And we call that, F1 prime. That's the shadow length, right, at noon of that thing. That's projecting it onto the XY plane, and then we're projecting it onto the X-axis, and then projecting that shadow onto the Y-axis, right? So that's this and that. These are right angles here. These are all right angles, which helps with the trigonometry, right? So F1 prime is going to be what? Sorry? Yeah, it's going to be the magnitude of the force 400 times what? Times cosine of 55 degrees, right? Why 55? Because that's 90 minus 35, the angle to the z-axis, right? It is a projection angle, although they're giving us some angles that we're not normally familiar with, but yeah, you can make that work. Okay. So that's F1 prime, and then F1x is going to be what? And we can crank this out if we want to. An octave Online, very nice program. You can just type, I need to know what 400 times the cosine in degrees, cos d of 55 is. That's 229.43. Okay. Oops, sorry, that's this thing. 229.4 is F1x. I mean F1 prime, and F1x is going to be 229.4 times what? Cosine of 20, right? And so in Octave Online, you can say, all right, you can take the answer, ANS times cosine in degrees of 20. ANS kind of holds a previous answer. That's a shortcut, 215.59. And F1y is going to be that times the sine of 20, positive or negative. F1y, is that negative or positive? It is negative. So that's going to equal also, you can use the up arrow in case you're using octave. It's very nifty, and to bring back an equation and just multiply that times the sine d of 20, which is going to give 78.47, and that will be negative. And finally, F1z is going to be 400 times the sine of 55 or the cosine of 35. $27.66. So that is our F1, and then F2 is going to equal, okay, so F2 is a direction angle representation, right? So that's going to equal and you can just sort of write it out, 400, the magnitude of the force times the cosine of alpha. What's alpha on this diagram? $45 plus cosine of beta, which is everybody knows it's 60 plus cosine of gamma, which is 120 times k. Yeah, so that is F1 and F2. And so now we have to take the dot product. These? 327.66 should be 400 times the sine of 55 or the cosine of 35. So we did step 1 and 2, and now we're just going to find the dot product, right? So step 3, so this is 1, this is step 2, and step 3. The magnitude of both of those is 400, so we just square that. And so the dot product is going to be the sum of the product of the x components and the y components and the z components, right? So it's going to be it's going to be 215 times you know, now that I'm actually doing this, I would have just ignored the 400, right? Because we don't really care about the magnitudes of those vectors, right? We just made the magnitude of those forces 1. It would have made our work a little bit easier. See that? And this is kind of how problem solving works sometimes. You know, as you make a few steps, you're like, I actually didn't really need to do that. You could decide to go back and scratch out the 400, but we're kind of stuck here now, so let's just continue, right? So 400 cosine of 45 plus F1y is minus 78.47 times, you know, 400 cosine of 60. Or you could just leave that 400 out and multiply the whole thing by 400 when you're done. A lot of ways of doing that. Plus this times 400 cosine of 120. And I think I can probably pull this down. Sometimes you can do this. Sometimes not. There it is. So I can maybe, I don't know, anyone got a number yet? Probably faster than me. Yeah, so I can multiply all this stuff out. This is kind of dumb for me to do this, but you get the idea, right? If you crank this out, you're going to get the dot product, and then you're going to divide that thing by 400 squared, and then take the inverse cosine. So I think I should probably finish and open up for any other questions, right? Now it's just basically arithmetic. Any other questions? Anything else? Because we only have 10 more minutes. Philip? On the second one, determine the length of the bar, the position vector. No, position vector is not always a unit vector. A unit vector can be derived from a position vector or a force vector by dividing by the magnitude of the vector. Yeah, so for this one, maybe that was to find the angle. So the solutions, you want to look at the solutions? So yeah, I mean, well, actually not to look at solutions, but the length of the bar. So yeah, so you basically have to start out, which is actually kind of silly. In order to find the length of the bar, you kind of need to find the position vector, right? You kind of have to do B before you can do A, right? But maybe they're trying to just mess with us, right? So we don't actually necessarily think of position vector first. You'd be going, how am I going to find the length of the bar? So yeah, so it's going to be to go from A to B. It's going to be right -4 in the x direction, +2 in the y direction, +4 in the z direction. So the length of the bar is going to just be RAB. Which is like square root of 36, which is 6. How nice. And then the angle theta is sort of it's 180 degrees minus alpha, right? If you were interested in that, you could find alpha, the direction angle alpha, and do that. Or you could do the dot product of RAB with, minus I, and then you want to just sort of divide by its magnitude, right? So you could do all that. Or you can make a unit vector first. The unit vector is sort of the dot product, isn't it? And you just sort of take the inverse cosine of that thing, right? I'm sort of going through this kind of quickly, all these ideas. But if you think of, so this angle theta, if you want to find that angle theta, should I write all these options out here? Maybe it would be helpful to see that. Option 1 is alpha is that, right? Find alpha, and then theta is going to equal 180 minus alpha. Because alpha is the angle to the positive x-axis, right? And alpha is going to just be the inverse cosine of -4 over 6, right? Yeah, do the inverse cosine of that. And yeah, or you could just say, okay, I know that, so option 2 might be to say theta equals the inverse cosine of r dotted with minus I over the magnitude of r. Because that's what the dot product is telling us, right? The dot product divided by the product of the magnitudes is the cosine of the angle between those two vectors, right? And that's what Dylan was saying. So he was just saying, well, if you dot r with minus I, you're only going to pick out the I term in r, right? I component of r. Multiplying it by -1, right? So theta is going to be the inverse cosine of -4 times -1 over 6, right? That's another way to do it. Joel, question? What else? So keep in mind the practice test is just sort of representational, so you should be comfortable with everything on the homework. anything on the quizzes. You know, so if there's anything in the homework that was kind of confusing, you know, you can ask questions on that too. Good. Yeah, the answer should be posted on that link. Did you try that link? So here's the test 1 link. I'll be doing this for all the tests, so you can just go there and pull up the solutions. Like so. Anybody want to see anything else? Anyone want to go through any homework problems? Yeah, you're allowed a formula sheet. What does it say here? It says you're allowed a calculator, 1 double-sided sheet of notes with formulas on it, no example problem solutions. Like you can't have any solutions to like the quiz problems on there, right? That would be unfair. You got to work those out by memory, and then you have 60 minutes to complete the test, and no bathroom breaks. I always feel weird about that. You know, sometimes people have emergencies and they really have to go. But I did have one student who it was reported on by someone else that this person was actually going on their phone. He would always go to the bathroom for every test. And, you know, they try to like look up the answers on their phones. You know. So if you do have to go to the bathroom, you have to leave. I have to pat you down for any electronic devices you may be having on your person. You know, it's so silly. Well, I expect to get a lot of perfect scores in this test, even with complex grading. First test is usually pretty straightforward. It's going to get more complicated as we go, but these are the foundations, and you've all been working pretty hard. I think these in-class sessions have really helped a lot. And I think the quizzes too, you know, I can see a lot of surprises on the quizzes. People take it a second time and then they ace it. So just work out all those little details. That practice really pays off. And see you tomorrow.